Okay, now here's the situation from Bob's point of view, sitting on Earth. Okay, he's sitting on Earth here, and he's looking up at the upper atmosphere. I've turned this sideways to have more room, and he's seeing the muons racing towards him at a velocity that's close to the speed of light. So the muons are produced up here in the upper atmosphere, right here, and they travel some distance, and Bob is basically looking at them coming in. Now they have to travel 15 kilometers to get from where they were produced to get to Bob. Now Anna is in a rocket, again, that's also traveling at the same speed, very close to the speed of light, right alongside the muon, and she's got a clock in her rocket, and so she's in the rest frame of the muon, traveling along with it. Okay, so from Bob's perspective, he observes the ticks on Anna's clock, okay, and those ticks occur at the same place in the muon's reference frame, okay, and so from time dilation we know that the time between successive ticks, the time interval between successive ticks on Anna's clock, is longer, according to Bob, than Anna. So again, from Bob's point of view, that is from the Earth's point of view, from the perspective of the Earth, as 2 microseconds ticks off Anna's clock in the rest frame of the muon, more time ticks off Bob's clock. Okay? So in the rest frame of the Earth, the muons have additional time. They have extra time to reach the Earth before they decay. So effectively their lifetime seems to be longer from the perspective of the Earth than in their own rest frame, and thus they will be able to travel further, and the observed flux at the surface of the Earth will exceed the flux that was predicted by the classical calculation, which didn't take into account time dilation. Okay, so the second explanation, is if we consider the situation from Anna's perspective, that is the muon's rest frame, and there what we find is that length contraction is the effect which causes the okay, let me get a ballpoint pen because it looks like it's going to be flipping. Length contraction is what explains the anomalous flux. So here what we have is Anna sitting in the rest frame of the muon. Okay, again she has her clock in her rocket, but now again in her rest frame she's stationary, and from her perspective the Earth and Bob are rushing towards her with a velocity that's very close to the speed of light, and so we know now that this distance, according to length contraction, so this distance, Earth and the Earth's atmosphere are basically moving through Anna's rest frame, and so according to length, the principle, sort of the consequence that we described, length contraction, this distance, the thickness of the atmosphere, is going to be smaller compared to Anna, as that is the object is the thickness of the atmosphere, moves through Anna's rest frame.